Section 1.1 Definitions and Terminology. This section will cover definition, classification by type, classification by order, solutions, and notation of differential equations. For definitions, a differential equation is an equation containing a derivatives of one or more unknown functions or dependent variables with respect to one or more independent variables. Classification by type. The first type is an ordinary differential equations or ODE. They are a differential equations that contains only ordinary derivatives of one or more unknown functions with respect to a single independent variable. For this example, dy by dx plus 5y equals e to the x. Y is the dependent variable. X is the independent variable. The second equation, dx dt plus dy dt equals 2x plus y. X and y are dependent variable, while the t is independent variable. The second type are partial differential equations or PDE. They are a differential equation that involves partial derivatives of one or more unknown functions of two or more independent variables. So the difference of these two types, whether it's involving with respect to a single independent or two or more independent variable. Notation. Leibniz notation or the dy by dx, d2y dx squared, and so forth. And the prime notation like y prime for the first derivative, y double prime for the second derivative, and so forth. These two notations are the common use in calculus courses. Newton's dot notation. They are used a lot in physical science and engineering because most quantity they are depending on time t. So find the derivative with respect to time. It's understood to be notation. Leibniz notation, which are dy by dx, d2y dx squared, and so forth. And prime notations like y prime for the first derivative, y double prime as a second derivative, and so forth. These two notations are the common use in calculus courses. For Newton's dot notation, like s with one dot for the first derivative of that quantity with respect to time, s with two dots on the top means the second derivative with respect to time of that quantity. They are commonly used in physical science and engineering courses. The subscript notation is very useful for partial differential equations since the dependent variable depends on two or more variables. So it's good to have the subscript to represent whether it's with respect to which independent variable. Classification by order. The order of differential equations is the order of the highest derivative in the equation. Like the first order, dy by dx plus 5y equals e to the x. We see the derivative part is dy by dx, which is in order 1 or the first order. mxy dx plus nxy dy equals 0. This is one of the exact equation form that we're going to learn later in chapter 2. See the dx dy, those tell us about the first order differential equation. The second order, as you see d2y dx squared, that's the highest order for this equation. Therefore, is the order of this differential equation. The general or normal form of differential equation is in a form that we let the highest order of the derivative by itself in one side and the rest of the terms will be on the other side. Some technique will require a certain form before you start applying the technique to find the solution of differential equations, which we're going to see more later on.